Okay, so in this video we're going to talk about relations and functions. So let's start with some definitions. A relation is a set of ordered pairs. A domain is a set of input values, also known as the x values. A range is a set of output values, or y values. A function is a relation that assigns exactly one value in the range to each value in the domain. This is really important that you remember. A function rule is an equation that describes each function. And function notation is when you use f of x to indicate the outputs. And again, this is read f of x. Can also be written y of x or h of x, but most of the time, this year at least, we will use f of x. Okay. Three very important concepts I want you to remember. The first one is you can determine whether a relation is a function by using the vertical line test or a mapping diagram. We're going to work with both of those today. So what is the vertical line test and a mapping diagram? Well, very important concept number 2. The vertical line test says that if any vertical line passes through more than one point on a graph, then the relation is not a function. And by vertical line, I literally mean drawing a line through a graph. So if our graph looks like this, I can draw a vertical line at any point. It only touches in one place, so therefore it is a function. But if our graph looked like this, if I draw my vertical line down, it touches in two places, and therefore it's not a function. 3, very important concept 3, the mapping diagram. The domains, x values, must all be different numbers. The range, though, the y values, can be the same number. So what this says is that every x value must have exactly one y. But the y values can repeat. So we will look at what that means in just a minute. Alright, so let's find some examples. For this, these first two, I just want to list the domain and the range. Remember that by domain, I mean what are the x values. For range, I mean what are the y values. So if we list the domain, talking about the x, so the 3, the 8, the 9, the 0, and the negative 4. And we can write it like this, 3, 8, 9, 0, and negative 4. Okay, the domain again is the x value. So then if we look for range, we're talking about negative 2, negative 1, 2, 3, 0. And 2, negative 1, 2, 3, 0. So let's come down here and do another one. Domain of this. We have 2, negative 2. 2 again, negative 2. And 3. And really I could have shortened this and just said 2, negative 2, and 3. There's no reason for me to repeat. When we go to list range, same thing, I don't have to repeat. So here I have negative 3. 3 is listed twice. I have another negative 3. And then I have a negative 2. If the number is used more than once, you don't have to write it more than once. Okay, so down here we want to know, is each relation a function? Well, remember what I said. Your x value or domain cannot repeat, but your y value can. So looking at this, here's our ordered pairs with our x's and our y's. So let's see, this x goes here, so that's good. This y goes here, that's good. This x goes here, this x goes here. So each x had a y. So yes, this is a function. No x values repeated. That's what we're looking for. What about here? Negative 2 goes with this 1. This negative 1 goes with this 0. This 6 goes with this 3. Well, what if I put in another ordered pair? Let's say that I said another ordered pair and I said negative 2 goes with 0. So I've added another ordered pair and I've said negative 2 goes with 0. Well, remember I said your y's can repeat, so that would be okay. But now I have my x used twice. So in that case, this would not be a function. So before I added this, yes it was, but when I put this in, it became a no. So remember, x cannot repeat. No repeating x's. Why can't x repeat? Let's use our vertical line test. Okay? So remember I said that for a vertical line test, you literally want to draw a vertical line down your function and see what happens. And if it touches in more than one point, then it's not a function. So here I have a straight line. The slope would be 1 over 1. I can draw a vertical line here. Touches in just one point. Okay, what if I erase it? Or what if I come over here? Draw a vertical line there. Touches in one point. So yes, this is a function. For this, each x has one y. Perfect. What about here? That vertical line touches in two places. That means that x is repeating, so no. This is not a function. What about here? Only touches in one place. Even if I drew another line there, it's still only touching in one place. This is what we call a parabola, and it's shaped kind of funny, but in reality, it still passes the vertical line test. Well, what about this one? Well, if I drew my line here, it passes, but ooh, look. If I draw my line there, it touches in a whole lot of places. This one has a whole bunch of repeating x's. As a matter of fact, depending on this, that has some slope that's actually vertical. So this would definitely be a no. So even though you could draw a line in some places and it only touch in one, you've got to consider your whole figure when you're looking at your vertical line test. Alright, so let's evaluate some function rules. This goes back to input, output. Your x is your input, your y is your output. So here we're saying evaluate f of n for negative 3n minus 6, or f of n equals negative 3n minus 6, where n equals 6. So what I'm saying is I'm going to plug in a 6 wherever I see an n. Okay, so here's my function, f of n equals negative 3n minus 10. But I want to substitute in the 6 for the n. So I'm saying f of 6 equals negative 3 times 6 minus 10. So when I solve that, I get negative 18 minus 10. So what I can actually say is that f of 6 equals negative 28. So in this case, my input was 6 and my output was negative 28. Okay, what about here? Evaluate y equals negative 2x squared plus 7, where y equals 4. Actually, that should have been x equals 4. Oops. Alright. So what I'm going to do here is substitute 4 for my x value. So my input is 4. What is my output? Well, when I plug in that 4, I'm going to do 4 squared, which becomes 16. So now I'm doing negative 2 times 16, which gives me negative 32. Negative 32 plus 7 gives me negative 25. Okay, so here's another one. Evaluate g of x for negative x plus 2 when x equals negative 3. So we're saying g of negative 3 is going to equal negative x plus 2. Well, remember that sometimes negative doesn't mean negative. It means the opposite of x. And in this case, our x value is already a negative. So here we have two negatives. What happens when you have two negatives? We're saying the opposite of negative 3. So in this case, we would say g of negative 3, negative, negative, we know what's going to happen there. We're saying 3 plus 2. So in this case, when we're saying the opposite of x plus 2, we find out that g of negative 3 is actually equal to 5. That negative rule still applies, even in this problem. Two negatives still become a positive. Okay, so let's look at one more way of working with functions. We want to find the range for each given domain. So I gave you the domain of negative 3, 1, and 4. So for each problem, you had to plug it in 3 times. So here, switch out. I said f of x equals x minus 6, and we had to use negative 3, 1, and 4. I have 3 x values, so I need to finish with 3 y values for each problem. So for this first one, f of negative 3, I said negative 3 minus 6, f of negative 3 gave us negative 9. Let's look at the next one. F of 1, because that was my second value in my domain. F of 1 would equal 1 minus 6, so f of 1 minus 6 is going to give us negative 5. F of 4, because that's my third domain value, f of 4 is going to end up being negative 2. Okay, what about the second set of problems? Y equals negative 4x. And I accidentally wrote f of 3, so that's okay. Negative 4 times negative 3 gave you 12, because I plugged it in. What about the second one? I changed it back to y equals, as I should have. Negative 4 times 1. For the second one, y simply equaled negative 4. So for the domain of 1, my range was negative 4. What about the third one? If my domain is 4, my range will be negative 4 times 4, or... Okay, let's move on to the third one. This time it's g of t equals t squared plus 1. So I'm going to plug in g of negative 3, which means I'm going to do negative 3 squared plus 1. Well, negative 3 squared is positive 9, because a negative number squared is going to be positive, plus 1. So g of negative 3 is 10. What about here? G of 1 gives us 1 squared plus 1. Well, 1 squared is 1, plus 1 gives you 2. And what's our third one? G of 4 gives you 4 squared plus 1. 4 squared is 16, plus 1 just gives you 17. So these are dealing with functions and function rules. Remember that the domain is your x values, your range is your y values. Remember that you can only have one x value, but you can have multiple y values. Remember that you need to know about the vertical line test and your mapping diagram.